Okay, so I think we can start. Thanks a lot again, everyone who was joined this online session. This session comes a week in the week following the final event of this EU-funded project called MORE, which developed tools and processes to reallocate road space in Europe and tested these tools in 5 European cities. This morning session in particular will introduce the tools that were developed or refined, as you will learn throughout the project. And we have with us the colleagues who have been working on these tools and will be able to present this to you. So I will show you the agenda for today. Of course, sorry if I didn't introduce myself. I'm Francesco, Ripa from POLIS, the network of cities and regions working on transport innovation. We're based in Brussels, and we were in charge of the communications and dissemination of the MORE project. So I'm very happy to introduce this session. I will let the colleagues in a few minutes introduce and say a bit more about the single tools, because you will see that then for half an hour, we will split into rooms according to your preference and your interests. Probably for your work, you are more interested in one of the tools that will be presented. So we will let you and guide you to select a breakout room. And there would be, let's say, in-depth dedicated presentations by Paulo Anciaes of the University College London, Robin Morrison of Buchanan Computer, and Peter Sukennik of PTV, presenting the tools. And then we will rejoin the main area to hear from the city representatives that tested those tools for 3 presentations and Q&A sessions with Andor Háznagy from BKK Center for Budapest Transport, José Pinheiro, who's been working with the city of Lisbon, and Per Wisenborn of the city of Malmo. We will also be monitoring colleagues who are entering in case we need to let some more people in. And as you will see, this is a meeting, so we can speak at any time, even when we don't are not aware of this. Okay, so I think it's an introduction. It can work as an introduction. I'm sure that many of you in the room have also attended the final event last week, either in Brussels or online. So I'll just ask the colleagues, Robin, Peter, and Paulo, to activate their camera so that we can really in a few minutes give a taste to the participants who are with us about what their tools are about and why they should join your breakout session. So Paulo, let's start with you maybe. So what you've been working on in the project.
Good morning to everyone. My name is Paulo Anciaes. I'm a senior researcher at the Center for Transport Studies at University College London in the United Kingdom. My interest is about equity in transport, so how the benefits and costs of transport policies are distributed among society. So I joined this project, which is about road space allocation, because it's aligned with my interests, because road space allocation and road design is about distributing a resource which is scarce, which is road space, and can be allocated to different uses, and has to be allocated not only in an efficient manner, but also in a manner that is fair and is sustainable also for the environment. So my work in this project, maybe I can present just one slide just to give an overview of the 4 tools, so the participants can situate the tools. Yeah. So I'm going to share my screen.
Also sharing mine.
Okay, you need to stop sharing.
Yeah.
And now I'm going to make it full screen. Can you see it?
Yeah.
Okay, this is an overview of what the role space allocation process is in most cases. It's a very simplified version. So it's based mostly on the modeling and on consultation. So there is a modeling of different options to redesign roads, and then the options are presented for public consultation, so the public can also tell their opinion. But what is missing in this process is a system to generate options, because what we start with, what we present to modelers, what to present to the public, usually is a very small set of options, or sometimes just one option. It's either the do nothing option or do something. So maybe we are not considering all the possible options, all the feasible possibilities to redesign the roads, because there are plenty of possibilities. Maybe planners are not even thinking of things outside the box, or things that are not usually implemented in their own city or in their country. So we need some way of generating a list of possible options. And that's what the option generation process is in this system. So one part of the MORE project was to develop a system to generate possible options. Maybe not all of these options will be feasible, but will generate a list of possibilities. So I'm going to present this in my presentation. I'm also going to present what is at the end of the process. Once we have the modeling results, once we have the results of the consultation, then we need to combine these results in a way that is minimally objective. And that is what is not being done right now. The decision is mostly political, it's subjective, it depends on lobbying, on political interests. So we need a way of combining the results of the modeling of the consultation in an objective way. So we developed in this MORE project an appraisal tool that combines all these results and try to produce a way of helping the planners and the politicians to reach a decision about which option to choose. So this is what I'm going to present in my presentation in the breakout rooms, and then my colleagues will present on the modeling and on the consultation side.
Exactly. Thanks a lot, Paulo. I suggest that you keep this slide on unless Peter and Robin have something else that they would like to share. But indeed, it's very useful also to show the full process that we developed in a sense. And as Paulo said, one of the strong messages of the project is to focus on this phase of generating options and to do that as objectively as possible. Also to consider some options that would not be otherwise considered. So I would like to ask Peter Sukennik of PTV, who will be presenting some developments on the PTV VISIM modeling tool. So presenting on the part in the middle, modeling and micro modeling. Peter, if you want to say a few words about your session.
Yes, of course. So I will talk about PTV VISIM, which is a micro simulation tool you can use to build up a model and perform evaluations and create nice visualization. And it's a tool you can use to answer the questions, what if? So what if you do measure A or measure B? What if you change your design? What if the volume will change? What if the demand will change? And such kind of questions. And within the MORE project, we improved the tool. So we added some new features, and we also introduced some new evaluations, useful evaluations for the MORE project. So I will show some slides and the graphic user interface as well.
Thanks a lot. Thanks a lot, Peter, for the introduction. And then we move to the consultation and stakeholder engagement tools. So Robin, that will be presented by Robin Morrison at Buchanan Computing. Robin, a few words about these tools before we split into groups.
Yes. So we developed 3 tools for stakeholder engagement. Is TraffWeb, which is a web application for the consultation process. So it allows public stakeholders to leave comments on the particular area you're looking at, or indeed fill out a survey on a design option that you've come up with and you've published online. We've then got Line Map, which is our road markings design tool. And this allows you to create digital representations of the designs and then publish them to TraffWeb. Both of these tools are widely used in the UK by local government. We had to modify them fairly extensively for the MORE project to incorporate different regulations across the different cities and incorporate the different processes that the cities wanted to use. And I'm also going to talk about the street layout toolkit, which was developed by University College London. So this is a physical design toolkit, and it allows you to come up with designs in local workshops with stakeholders who have an interest in the local area. So I'm going to discuss how the tools work, give some demonstrations on how they operate, and discuss a little bit about some of the designs that the cities came up with, and the issues that they created and how we solved those problems by enhancing the software throughout the course of the project. Thank you.
Thanks a lot, Robin. So this will be, let's say, the object of the breakout rooms. So these tools presented in details by the people and the colleagues who will develop them. And then, as I said, we will gather in the main room, in the main session, to hear from the city representatives that have worked and experimented on this with these tools. So now we will try this magic. So you are not pre-assigned to any of the rooms. So we will leave you the option to select which room you want to attend. The first one is option generation, presented by Paulo. The second one is micro simulation, presented by Peter at PTV. And the third one is stakeholder engagement, presented by Robin at Buchanan Computing. So I will now open the three rooms and I will let you select yours. One comment for the colleagues who will be presenting: if you can please hit the record button when your parallel session starts, because the session recording, my session recording, will not be able to grasp the single sessions. So I will now open the rooms, and I see that all participants have been invited to join breakout rooms. So please feel free to select a room, and then the colleagues can start their presentations once we have assigned most participants.
I can't see anything how to select a room.
There should be an option in your dashboard called breakout rooms. If it's not in your screen, it's probably behind three dots.
Click on more, actually, the three dots and then more.
Exactly. So
I don't have it. Just put me in room 1.
no, don't worry, Menge. I can also assign you if you tell me which room you would like to attend. So,
yeah, the first one.
Great. Okay. So I think I'm here talking to the people who have stayed. So don't hesitate also to activate your camera and audio to let me know which one you want to attend so that I can help you. So we have quite a few people to the session on option generation and appraisal, which is the first one. The micro simulation tool presented by PTV is very interesting, with a lot of things moving. and the tool is very extensive and comprehensive. Great. So Daniel, it's only me and you. Bravo. Great. So let's go. Daniel, feel free to go to the room that you want. I'll go to the, yeah, great.
Morning, everybody. Great. Morning, everybody. I'm Robin Morrison from Buchanan Computing, and I'm going to discuss the stakeholder engagement tools that we developed for the MORE project. So during the course of the project, we developed 3 tools. As I've already mentioned, TraffWeb, which is our online public-facing web application for consultation. And this covered 2 stages of the stakeholder engagement process, issue and design consultation. There was also the street layout toolkit developed by University College London. And this is a physical design toolkit. And the idea is that you have a local workshop and invite stakeholders to sit around a plan and come up with different design options. And then Line Map, which is a road markings application, and that allows you to create a digital representation of the designs that you've developed in a local workshop, and then publish them to TraffWeb, the public-facing application for consultation. So this describes the 3 stages of consultation that we carried out. So issue consultation. So we defined a particular area of interest or a study area. And the first step was to try and collect issues from stakeholders, suggestions, and their comments regarding the current situation within the study area, about traffic levels, any road safety issues, parking issues, or public transport issues that they felt were occurring.
Thank you.
Oh, you have.
Okay,
So I
fine.
don't need it.
Yeah. So I'm going to share my screen again. Okay, so this session is about the new option generation tools that we developed in the MORE project. These tools are online. I'm going to show later how you can access the tools. I'm just going to give an overview of what the tools are, what are the inputs, and what are.
So the green boxes represent the tools themselves. So TraffWeb for issue consultation, then design options with the street layout toolkit, then digital representations of the designs using Line Map. At this stage, we could then export to the Vism modeling tool. So the road marking designs that you created could be exported as an overlay to enhance the modeling. Then we can publish the designs to TraffWeb for feedback during the design consultation. And then based on these results, analyze the comments from the consultation process. And then we can feed back to Line Map to refine the designs further, or you could take the design further and then make a decision on whether to go forward with the design or not. So we'll look at the TraffWeb first. So, because this was the beginning of the process, so it's a map-based web application for public consultation. And throughout the talk, I'm generally going to talk about two types of users: stakeholders, meaning members of the public, but also people with other interest in the area. They can use TraffWeb to record issues within the area of interest and also provide feedback on any designs that are created. And then the designers themselves, they can log into a secure area for dashboard reporting and also download the results for further analysis. So for the issue consultation process, we created a form and stakeholders could make multiple comments covering the general study area or specific locations within the study area where there's a problem. They could then categorize the issue, whether it was to do with air quality, parking, congestion, road safety, and also choose whether or not the issue only occurred at a particular time of day. So the morning peak or the evening peak, or possibly it just occurs all day. And then stakeholders were encouraged to provide further details to aid in the analysis. So their location, either within the area or out with the area, name and email if they wanted to, and then their particular interests in the study area, whether they were a commuter or a business owner, and then what modes of transport they use within the area. So this is an example of the study area that was created by Transport for London. Covers an area along a road, busy road, the A2. And on the left-hand side of the screen, we have a definition of the area itself and a list of streets. So stakeholders can click on a particular street and that will take them to that area on the map so they can quickly navigate around. The map itself is interactive, so you can pan and zoom around to get yourself orientated. And then we have these two tools here. The top button allows you to plot a specific location on the map and report an issue at a particular place. And the second option then allows you just to make a general non-location based comment about the whole area. So that then produces a form where we have our two categories. So we can categorize the tool by its type, road safety, parking, congestion, etc. Then define a particular time of day and then add a description of the area itself. And stakeholders were encouraged to add as many issues as they felt occurred within the area. You didn't just have to enter one issue. So once that was complete, we then produced a form to try and get some feedback on the responder themselves. So again, their interest in the area, what they did within the area, and then the modes of transport that they used as well. And then there were options to leave comments on any other suggestions that they felt were relevant. So this tool could either be used self-service, so it could be advertised through social media, and stakeholders could just access the website, use it themselves, but also it could be used as a survey tool. So some cities chose to actually go out on street with tablets, and they interviewed people and then recorded the details within the tool. So the designers can log on to a secure area, the dashboard, and this gives them feedback on the results. So you get a map of any issues that have been plotted by the category or time of day. So this is the colored dots at the bottom, showing the different areas. And then graphs showing a count of the different types of responses according to the category and the responder. And this information could be downloaded as an Excel spreadsheet, and you could carry out further analysis, create pivot tables on the results, etc. So this was completed by all cities by the end of 2020. And we collected over 700 issues from more than 450 responders. And in addition, the city of Malmo actually conducted an on-street survey, recording not just the issues, but how people felt about the area. So they had a special survey attached to the TraffWeb system, and they recorded 1,300 responses over about 8 days worth of surveys. So in general, the tool was felt to be very easy to use, quite intuitive, and produced some good results. So that was TraffWeb, and we'll come back to that later when we start looking at creating the designs themselves. So we're going to now look at the Street Layout Toolkit. So we've collected our issues, and we've got some feedback on particular problems within the area, and we can then look to start creating new designs for improving the area. So the Street Layout Toolkit, it's a physical toolkit, so it allows you to conduct local workshops or design days, and it allows local stakeholders to collaborate on the design process. So they can try out different combinations of street design elements on scale plans. So different configurations of loading bays or bus stops using fixed sized blocks. And then for longer road use elements, such as bus and cycle lanes, they could use acetates. In terms of the process, so each design day went through a particular process. They were given a briefing on the current conditions. Then, depending on the size of the group and the number of stakeholders and the size of the study area, groups could be divided into smaller groups to look at particular junctions or particular areas. Then there was a distribution of all the components for the kit. They'd be briefed on the fixed conditions within the space, and then asked to come up with designs for the remaining space using the blocks and acetates. Once they come up with a design, the design would be fixed and annotated. So briefing on the current conditions. So this would involve telling the stakeholders about the current traffic regulations, particular businesses in the area, what public transport was available within the area. They'd be then briefed on the issues that have been collected. For example, high traffic levels or a lack of green space. And then any objectives were then agreed by the participants to make the area a better place. So, as I mentioned before, the groups were then possibly divided into smaller groups to look at smaller areas, or they would just sit in one group around a single plan. And then invited to orient themselves on the street and familiarize themselves with the street plan. So looking at the actual components themselves, the kit consists of a scale plan, 1 to 200, showing the road layout and the existing building lines. They're then given a box containing fixed length road use items, such as loading and parking bays, and then acetates representing bus and cycle lanes and longer linear items. A set of pens to annotate the plan and mark little points of detail, and then also a set of stickers to fix the design created using the blocks. So this is a close-up view of the blocks themselves. So we have parking bays, bus stops, disabled parking bays, which are all of a fixed length. And you can have a single bay or double bay. These kits can be made up however you need them. So once you had your groups created and people had orientated themselves around the plan, they were then informed about the fixed conditions. So the building lines could be fixed, certain curb lines could be fixed. There may be minimum requirements for the width of the footway. But also there would be areas on the street, on the road, that you couldn't put parking bays, such as around major junctions. So there'd be certain areas where they'd be prohibited from adding blocks. So once this information had been relayed, they'd be then invited to create designs for the remaining space. So here we have an example of a workshop in process. And generally this process was very well received. People enjoyed being involved in the design days. And an innovative use of a design day. So this was occurring during COVID restrictions when you couldn't hold meetings inside. So this is in Lisbon, and the design workshop was held out on street so people could walk past and get involved that way. So the final step, once a design had been created, once a consensus had been reached, the blocks that we're using would be fixed with stickers or replaced with stickers. And the design would become fixed so that it could then move on to the stage of being digitized. The pens would be used then to modify and annotate any curbs that needed to be altered, and they could just be drawn in at this point. So here we have an example of a final design. You can see the blocks coming down the side with the footways, then cycle lanes, parking spaces and bus stops. And this was created by the city of Malmo. They added to their toolkit by having some 3D printed little models of trees, pedestrians and vehicles, just to kind of add to the interactive experience. So once the design itself had been created and fixed, we could then create a digital representation of the design. So for this, we use line map. So this is really aimed at the designers themselves. So it's a map-based road marking design tool. It's available from the cloud. And we create digital representations of the designs created using the physical toolkit. The designs can be created as blocks to mimic the street layout toolkit, and these can then be turned into accurate road markings and added to for extra detail. So here we have the user interface for line map. So you have on the left-hand side a road markings explorer. So this contains a library of different types of road markings, which you can create on the interactive map. And to this, we added a section, which is the blow up on the screen, which shows the different types of blocks and the different colors. On the map itself, we're showing an example of a block-based design. So we have a bus and cycle lane going down one side of the road and various parking options on the north side. This could then be converted into accurate road markings themselves. And we found during the process of developing the tool that every city had a different set of road markings, and we had to modify our library fairly extensively to add lots of different road marking designs for different types of parking space. So once you've converted your road road blocks into markings, you can then add further details such as text and direction arrows onto the map. In terms of actually drawing the blocks into the system, we have a process or a concept of construction lines which you can create. That's these green elements here. And you can simply select a block from this side, click on 2 points along the curb, and we have some curb following tools that will allow you to create a block very easily along one side of the road. Some of the elements have variable widths, so we can modify those before plotting. So here we've just created a cycle lane down one side of the road, and now we're putting in taxi bay, some car parking, and I think a loading bay along the other side of the road. So in most cases, especially when creating blocks, you just need to click 2 points, and then we can use those 2 points to make a construction line, which is the little green line that appears there, and then plot to create the blocks. So very quickly, you can recreate a design from plan into line map. We can then select the blocks and convert those into the road markings themselves. So that's the process that's going on at the moment. So we're now just looking at the road markings. Not all road markings can be easily converted, and we may need to add some further detail to enhance our design. So for instance, on the cycle lane, we might want to add some directional arrows. And those items can be drawn in a fairly straightforward manner. Other items, we have a fairly extensive range of construction line tools. We can offset from the curb, draw things in freehand, or create fixed length items for a particular number of parking bays. So the idea is that you, just through a series of construction lines, can create these accurate road markings on screen. So more complicated items can require more than one construction line. So for example, to create a pedestrian crossing, we would create a construction line down the center of the road, then an orientation line to show where the crossing is going to occur. And then based on those, we can click on the plot button and the software will then calculate and draw the pedestrian crossing in for you. So we had to create lots of different road markings for the cities, and we had to delve deep into our systems to create lots of different new road markings that we hadn't come across before. A couple of other things that line map can do. So variable width blocks and markings. So for example, a cycle lane could be created from 0.5 to 3 meters at 0.5 meter increments. So you weren't restricted to particular sizes of elements. And you could also create shared use space by stacking blocks one on top of the other. So for instance, you could draw a block and define it as a parking bay, which was in force between a particular time. And then you could draw a loading bay on top of that and then have that bay in force at another time. So then you could create a shared use space. Here's an example of a design that was created. This is the area of study in Constanta, and this is the block designed for their current situation. So pedestrian crossings, lots of general traffic lanes and footways. And that could then be converted into markings with the direction arrows added. Sorry about the resolution of some of these images. It then became apparent that there were lots of modifications required to the curb space itself and the footways, which was something we weren't used to. We were used to dealing with fixed maps and fixed roads. But within this project, there were modifications required to these elements. So we came up with a concept of having surfaces, and we could define any type of surface, whether it was a pavement or a tarmac road area. And then you could start with a base map, create some blocks for a footway, pedestrian or pedestrian refuge, convert those to surfaces, which then matched the base map that you had, and therefore build out the curb at this particular area. And you could also draw those in freehand just to build out the map. And then going back to Constanza, so one of their scenarios involved putting in an elevated section of road over the this junction. So using surfaces, we could create a surface called road bridge, and then they could draw that in and then add the markings on top. So they had two views of this design, one showing the ground level and then one showing the elevated section. So this again was something we hadn't done before. We quickly had to come up with a solution for it. So other things that LineMap can do, it can provide reporting tools and exports. So we can print scale plans of our designs from A4 to A0. We can generate reports listing the design details, such as the number of bays in the design, the lengths of individual elements, so how much cycle lane, what length of bus lane we have within the system. We can then export the designs in most sort of popular mapping formats for CAD, but also to act as an overlay to add detail to your modeling package, such as Vism. And then finally, the final part of the design stakeholder engagement process, you can publish the designs to TraffWeb for consultation. So here's an example of a design published within TraffWeb. And this is you can publish both the marking and the block, or just one of the type views of the designs. But the block design gives you a really good high-level view of the different road uses within the area. And then as you zoom in.
Robin, had you picked up they're closing the breakout rooms in 20 seconds?
Yeah, I know. I thought I had I've got 4 minutes left. Okay.
Oh, right.
So here is a view of the detailed markings themselves as you zoom in, and you now get a survey for the design. And you can fill out a survey about the different street uses, whether you feel it's not enough or about right, or to the dashboard for results. Thank you very much.
Hello, apologies if I hope this was not disruptive for your presentations, because our timer was set for 30 minutes.
Yeah, I got cut off a little bit, but
it was a little bit.
Sorry, but can you please, if you have to finish your presentation, shall we just do that now, so that if it's only a few slides, I think that would not be a problem for everyone else to listen.
I'm pretty much finished. I think I got there in the end.
Okay, I was for you, Paulo.
We had some problems. It was impossible to record.
Okay.
Yeah, but I have one last slide I can show now, and I think it applies to all the three tools. So
please, let's do this round so that the colleagues can end their presentations, and then we pass to the city presentations.
Yeah, can you see my slide?
Yes.
Okay, this was the final slide. I didn't have time to present this, but it applies to all three presentations. So it was just to say that the tools were trial in 5 cities across Europe. These are the cities, always in busy roads that link to the Trans-European Transport Network. And in the case of my tools, we got feedback from road user groups representing pedestrians, cyclists, public transport, and also the freight operators. And then a last slide. This is where the tools, the option generation tools, are located right now, and also the project website and my email.
Great. Thanks a lot, Paulo, and apologies for this for this for the fact that the session ended while you were presenting. So, Robin, do you want to say a few words to conclude your presentation, or?
I think I got in just before I got cut off. But yeah, if anybody is interested in any of the tools, we have the website for TraffWeb online, and you could contact us and we can let you have a look at the system. And again, if you're interested in the line map or the street layout toolkit, please get in touch.
Great. So probably we can say more about these tools also while the cities are presenting. And Peter, on your end, you managed to present the whole microsimulation tool and the functions of PTV Visim?
Not exactly, but if you give me 1 minute, I will go through the last slides.
Please do that.
Okay. So if you allow me to share my screen. Can you stop sharing so I can start mine? So now I'm back there. Okay, so I came up to the visualization. I will just mention that we also implemented several parking states, so you can see what's going on in your model, because you can color the vehicles by the parking state. You can use different kind of visualizations for pedestrians.
Peter, we cannot see your presentation if you're sharing.
You cannot see it?
Nope. Now we can. Yeah. Now we can. Evaluations for pedestrians.
So now it works. Okay, so
yeah.
For pedestrians, there are several types of evaluations you can choose from. There are also new evaluations for parking lots, group spaces, and so on. And there are also new attributes for the evaluation. And these are resources I recommend if you are interested more into detail, or if you have some questions, you will find here tutorials, guides, examples with descriptions, or if you have any question, then please send me an email, contact me, and I'll be happy to answer all of them. That's from my side. Thank you.
Thanks a lot, Peter. So I think an opportunity to go back. So just to remind participants that we are in a meeting, so to please mute yourself if you're not speaking, if you don't have questions. So now we'll probably have an opportunity to go back to these tools through the presentations of the cities that tested them. I think it's just nice to see how these worked in practice. So we have Andor, Háznagy from BKK, the Budapest Center for Transport, José Pinheiro of the city of Lisbon, and Per Wisenborn of the city of Malmo. So Andor, are you with us? Are you happy?
Yeah, I'm here.
Are you happy to activate your video and audio, and to please share and start your presentation? Also introduce yourself and say what you've been doing in the project.
Okay, I'm starting sharing my presentation. I hope it will be working now. The slides are moving. The slides are moving. Yeah, I think, okay. So first of all, thanks for the opportunity. My name is Andor Háznagy. I'm working for BKK Center for Budapest Transport, and Budapest is part of the more projects. Some words about the city. It is a capital of Hungary. It's economic tourism.
Sorry, Andor, if I interrupt, but we are not seeing the presentation mode.
Oh, I see. Now.
Now we can see the slides. Still not impressed. Oh. Yeah, great. Now it's
okay.
Now it's better. Maybe. Yes, please.
Okay. So the Budapest is the middle of the Central Europe. It is really important transportation educational center, and in the functional urban area, more than 18 towns are situated. So more than 2 million people live the neighborhood on the city, and I'm from the BKK. BKK, the Center for the Best Transport, is the mobility manager of the Budapest. So we are responsible for all travelers regardless the purpose, the and the mode of transport. No absolute priority among transport modes. I mean, we are managing public transport, shared cycling system, parking, taxi, road maintenance, and so on. So we have a lot of work to do. Some words about the analyzed feeder routes, which we analyze in detail to the more project. It is a very famous road. It's situated in the middle of the street. It's the connection point to the central, to the TEN-T corridors. And you can see in the pictures that this part is built for the cars with a lot of great separated intersections with several lanes for car traffic and the minimal space for pedestrians. So we have a lot of work to do. And some words about our stress section, which has been analyzed in details, the formally explained tools. It is Kossuth Street and the Rákóczi Road. This is the main boulevard of the street, but originally it's built for the peoples. But in the 70s, they are reshaped for the cars. You can see some pictures, and there are some interventions during the last years, but also we have several tasks to do until to get the sustainable streets looks out. So now you can see the streets. Now it's look like these ones. Okay, so we started to our process with collecting our data and identifying the design process. This was, and next to that, we gathered all the available strategies and ways how can we form the streets. That was important before we start to use our tools to get adequate inputs for them. So we have managed really detailed traffic surveys on the street that we count the traffic, the pedestrian, the public transport users, the taxis, and so on. We have a lot of KPIs from TV Tristan. They are also part of the project. So we have everything for using the tools. Next to that, first of all, we use the TraffWeb. It was live in 2020 autumn. We have approximately 200 comments. How can we relocate the street? What is the problems? What can be your solutions? So there are some general comments of traffic calming, pedestrian crossing, in using cycle lanes. That you can see cyclists on the picture. That is really dangerous because it's on the bus lanes, and in the peak hours, every minute goes through one bus at the section in each direction. So it's really hazardous to cycling on the road nowadays. So maybe Robin mentioned that these pictures from the dashboard of the TraffWeb, it was really, it gives really useful results. You can see dots each of the problems, like pedestrian provision in red, cyclists in gray, and road safety issues in blue, and so on. And next to that, this gives some charts also, this dashboard. And next to that, we summarized for, based on the space, we collect the main problems and issues what our participants enforce. So you can see we managed the whole the traffic consultation, the whole accuracy axis. That's indicated in the blue arrow, and in the green arrow shows that the stress section of the more projects. So we have global views, what can we do at the stress section. Next to that, we managed the design days in the summer of 2021. We invited mayor's office and other municipality-owned companies like Budapest City Planning Ltd, Budapest Horticultural Ltd, Budapest Transport, and Budapest Public Road Ltd. And also we invited the chief architect and the chief landscape architect also for the design days. We separated one from urban aspects, one for transport aspects. You can see in the right that pictures from the design days. It was really useful. And you can see that every participant was really active. So we managed the design days with a unique methodology. First of all, the participants get familiar with the Rákóczi Road, the stress section, what the current condition looks like, what the problems, what the future views about it. So the participants have a really good base before the work with blocks and acetates started. As earlier mentioned, and the pictures show also, we printed a map, and the participants can put different lanes, pedestrian crossing. They can take some notes about it. They can argue with each other what the possible solution for each of the cross sections. So in this methodology, we have some outputs for the current condition and the future conditions also. Yeah, so in the current conditions, the main of the variants was the curbside remains, but in the future, the people has used their visions in much more deeply. So you can see several pictures. This was really useful, and it gives a lot of input. So we take several notes and several pictures, how the street section looks like, what was the people's comments on it, and based on these informations, we can use it for option generation. Okay. Next tool, we use also the option generation tool, as Paulo mentioned in this our slides. The policy intervention tool and road design tool was really useful to manage the possibilities of what can we use during in the process, what's not, and so on. We selected from the list some important interventions, like giving more space for cyclists and pedestrians and less for the cars and so on. And based on these requirements, we've got the good solutions and how the redesign look like. So it was also really good, useful tools. Next to, we have a lot of inputs. So we have inputs from TraffWeb, inputs from design days, not just the current layout, but also what the high-level expertise and decision makers think about the road, and what the tool says. And based on them, we have managed with our colleagues with other running strategies and possible solutions, like what's the parking situations, taxi, micro-mobility, city logistic, EV chargers of the city and the surrounds of the stress section, the Rákóczi Road, and where can we put the cycling lane? It's kind of difficult, and based on these outcomes, we can make 3 different scenarios. Basically, the urban, the sustainable approach, the transport approach, and also a mixed version. This section is really, it's like a tunnel, so they are not so squares and so on. So the scenarios are really similar to each other, but we have some play the game on the squares to give more space on the pedestrians and so on. So based on these actions, we manage the scenarios. You can see some description here. I don't want to write it all. I just show you, yeah, you can see the short-term outputs, that's approximately 2 years ahead. The same was of the version that we keep the curbs and we use the parklets when we narrowing the space for the cars, and the bus lanes next to the curve sign or in every variation. You can see some differences. Now I can just zoom in. That is the place of the pedestrian crossings, and the cycling lane was the main issues. And in green you can see some space for green areas and parklets to sitting for peoples, and some gray areas for city logistics and micro-mobility points, this area. And in the next slide, you can see long-term future outputs. They have some major changes from the current condition, that you can see also that basically in the starting section where we put the bus lane, cycling lane, and how wide the pedestrian areas and the cross sections also. Next to that, we've got these scenarios. We use the Visim for modeling. It was a really hard work because it was a really long session, and we have to combine the car traffic, the public transport traffic, the taxi traffic, the pedestrians walking on the street and walking to the bus stops, and the cycling traffic also. And we put several new pedestrian crossing. We decided to manage it with traffic signals, so we have to plan signal phases and signal plans and so on. So that was a really hard work, but we have a really good company who have managed these works. So after we build the VC models, we run we run them in a different random seeds for get different scenarios. And next to that, we analyze for time of day in the morning from 6 to 9, in the daytime to 11 to 2 p.m. Afternoon from 4 p.m. to 7 p.m. and evening from 7 p.m. to 10 p.m. So we have 4 different scenarios for different time of the days for each time frame, for the short time ahead and a long time ahead. Also, we've got these results, and we applied the KPIs which we got from TU Dresden. for they need the main basically the same results from each city to get their cross section the comparison work. So we have speed, density, and level of service, and so on. We have a lot of parameters which we managed. There are some summarizing table you can see now. So that you can see that version is the current condition, and you can see how to change the traffic flow at the section. What caused some questions that, as I mentioned in an earlier period in my presentation, the Budapest has a microscopic traffic model for strategic planning, and we use this model for getting information what happened in the road when we reducing the lanes and so on, so how to change this traffic and the whole city. And we use these inputs, refining the already existing traffic counts for the future traffic flow. And we've got that the section is full of congestion, basically, yeah. And next to the pedestrian traffic, we have we think about that is changing from in a small amount of from the current situation. The problem was that it's really difficult to define how many pedestrian, how give more that section if we have a wider traffic lane, wider lanes for or area for pedestrians. So we have some results based on that, and just to recap slides that about the more tools. That was easy to use, that we use for co-creation, it's helpful for problem exploration and scenario building. It helps also the professional dialogue and the use of these tools, and make good notes and so on. And making a very detailed variation, it takes a lot of time. So sometimes in practice we have really short time to decide what we have to do. With this model can help this decision-making process, but we need more time than in the former experiences, how we are doing. So that was my short presentation. If you have some questions, please ask.
Thanks a lot, Andor. Indeed, we have a few minutes for presentations. If there are questions from the audience, you're free to write them in the chat, or just to ask your question out loud, as you are able to do that in the Zoom meeting. Otherwise, we'll keep monitoring the chat and regroup the three city speakers at the end to take questions if some more come afterwards. So thanks again, Andor, for the presentation. And we'll move on to José Pinheiro from Lisbon. Hello, José, please introduce yourself, and the floor is yours for your presentation. You can see your screen. But we cannot hear you. We can see the screen, but we cannot. Nor see you. So.
And now,
now we can see you and hear you.
Great.
So the floor is yours. But we cannot see your presentation anymore.
Yeah. I'm sharing the screen. Now you can see, right?
Yes, it's perfect.
Sorry for this. Hello, everyone. My name is José Pinheiro. I work on this project for the Lisbon municipality. I will focus my presentation on the modeling tools mostly. I will give a brief context of the project and the tools, and then I will present the methodology for the simulations and how we evaluate or analyze the indicators. So first of all, I want to give a brief localization of our street for people who doesn't know. Our case study is Rua Moraes Soares and Praça Paiva Colseiro, which are located on a very important connection between the eastern and the city center, its eastern side and city center. This is 10T, so they provide a very important connection to here, which city center here and historical center, and through here to again to the city and to the business center also. These street and square are very interesting actually, because they are the most now with all the tourists on the past years. I think this street is some of the most neighborhood local activity, with a lot of people walking by and using the street to go to local commerce, with even with traditional commerce yet. So it's very interesting, but it has diverse activities. We are speaking about movements and parking and pedestrians, and it's a very, very important street for public transport also. We have a headway in each direction of 1 bus per 2.5 minutes on average. So it's very difficult, and it's parking is you have a lot of demand for parking, and abusive parking, second lane park or double parking is very common without supervision. And this is the look of the cross section, a typical cross section in our street. So we see that we have 2 lanes in each side, parking in most of the cases, as we see in the photo, and a very, very narrow sidewalks for each pedestrians. We are speaking about, I don't know if you can see here, but 1.6, 1.8, and this is the common width here. This is a square. The square is very interesting because we have a large park with benches and places people to sit, drink a coffee. It's very interesting. But this city is, the inhabitants of this city are sometimes elder people. So, and the square is located in almost in the middle of urban highways with 3 or even 4 lanes on each side. So it's sometimes a bit dangerous to cross by. So for this work, we made an intensive and extensive data collection. First of all, we looked to the population in the surrounding areas. I already presented this on last week, but we have a buffer of 100 meters around the case study. We are speaking about a population of 6,000 people, but if we increase the buffer to 500 meters, it's 30,000. So it's a very populated place. We looked at the economic activities, tried to find the patterns, the movements that originated by the stores. We have around 170 stores and commerce and establishments in 600 meters. It's a lot. So this creates a very, very interesting movement, but confusing also. And we looked at the curbside activities. We made an analysis of each point in one day, how they are occupied, and tried to know how the difference between the use of metered parking and load and load. So we also made a distribution of time for each type of parking. We also try to know where, I don't have that image here, but know where are the most frequent locations for double parking also. So we have a very, very interesting data collection for parking. Public transport, of course, with data of our municipality company, transport company, Carris. And of course, we made countings for traffic, but also counting for pedestrian, which we in Lisbon we don't have that kind of data, so we had to create. And also we made service to shopkeepers, residents, and visitors to understand their patterns of movements. How do they go there? How many times per week? And most of all goes there by, well, about 21% uses the street. Who uses the street goes by car, 26 public transport, 40% walking, and the rest are the other modes. 45% walking, I think. So it's a very local street, and people use it every day. Now, most of them. So we made a huge collection gathering, and it was very interesting to know this, and we use this to construct a model, but I'm go there. So we use the other tools like the roads and the policy tools, but I will skip that and speak a little bit of our solutions then to the simulation. So we made three steps for stakeholder engagement. First, the first interaction was with TraffWeb, where with the online tool, people participated in it, give their opinions, comments, suggestions, and we had 150 comments, and it was good to know the perception of people about the streets. And most of the comments was regarding pedestrian, lack of pedestrian, or lack of quality of the pedestrian space. Another was the double parking. A lot of double parking. The right lanes are used mostly for double parking, so it's a mess and creates traffic. And was these comments that was very interesting, because we weren't aware that people have this kind of opinion. So we made the public participation through blogs and acetates. We made that sessions on the streets and invited people to participate and say to us, how do they think it will be interesting to have the street? And besides that, we also made the online sessions with stakeholders from the municipality department, the parish council, and the disabled and pedestrian associations. And so all of them give their opinion and comments about what should be the priority for each street. So considering these three steps, we started to simulate 5 scenarios, 4 for the street and 1 for the square. But first of all, we made the micro simulation. First of all, we made the current scenario, calibrated the current scenario to simulate the other scenarios. We made it simulated for AM and PM peak only, and actually they are quite different. The AM peak has less traffic on general, but it's more unbalanced. Most of the traffic goes from east to west, and the difference for the opposite direction is high. In the PM peak, despite the traffic volume is higher, general traffic volume is higher, the directions are more balanced. But even so, the direction from east to west, you have more traffic from east to west, even so. for the modeling, we use. Sorry. Okay, we use the data, the collection, to construct the model. In Lisbon, we have the macro model between zones, but we use it for the movements between the zones in the model are very high, and now we are starting to work on micro. So we use the countings to build the model, both for traffic and pedestrians. And as I told, you have 4 scenarios for the street and 1 for the Praça Paiva Coceiro. And first of all, it's precedence to parking. So reduce 1 lane in each direction and transform the parking, the parallel parking into diagonal parking, and increase a little bit the width of the sidewalks. The bus lanes, so basically we changed the right lanes into bus lanes, but we still allowed parking and right turns. So we don't know, maybe it doesn't work so well. Then we design a cycle lane in each direction, in each side, reduced 1 lane, and kept the parking space on each side. And then the fourth, we let the right lane we transform right lane into bus lane from east to west, which has more traffic, kept 1 general lane, and then in the opposite direction, we reduced to only 1 lane. And then we had in some cases, we have diagonal parking in one side and one side, which allowed us to increase sidewalks width and create some base that people can use for public space, for terraces, everything. And this is the scenario for the Praça Paiva Coceiro, which first I don't have here the comparison, but to nowadays, this is the lanes, general lanes, and this scenario proposes to remove this, have a continuous space between the square and the street, and then change this is nowadays in this direction is a 1-way lane, and then we have to change into 2-way lanes. It was very complex to make simulation because it obliges we have to have several left turns, and it wasn't easy to have a good result. So as I said, this is a simulation. We are comparing current design, with the 2 solutions that provide more space to the public, to the pedestrians, to place activities. It was what we wanted to show that we could have more space for pedestrians, even without. This is the current scenario, a lot of double parking, but we wanted to provide more space for people and show that we could do that without harm a lot movements. So it is possible, okay? And as we see in here, we have very narrow sidewalks, and here we can have trees and benches, and people have more space to walk. And here we can discuss if the trees on the middle, or if we can take advantage of these. How do I say? I don't remember. This corridor of trees could be transferred for here. So it was this kind of things that we wanted to work on. So I will show a bit of our methodology. For this, we made the simulations and we have several indicators. We tried to have somehow to provide a dashboard of this, so we can show, so we can have a more agreeable way of showing, of comparing than the graphics from Vissim. So we made an analysis by node. For instance, we know, I will try to show, the computer is slow. Okay, now we know how many vehicles are, let me show the whole, how many vehicles now we can compare. As we see, the design 1 and 3 have problems of capacity. So we have problems, design 1 and 3. Design 1 is the parking, diagonal parking, and the 3s are the cycle lanes. And this is the kind of indicators that we have. As we see, design 0, 2, and 4 in that direction is not a problem. So now we can conclude that having one lane on that direction may be problematic. So we may need two. And if we change the right lane into a bus lane, in sometimes it will be better than leave it to general traffic and double parking. So our conclusion is that double parking harms more the traffic movements than having a bus lane there. And on the opposite direction, where we may see that according with the capacity, one lane may be enough. It's not that different. And the delays, the number of stops are not that different. So we may reduce from 2 lanes to 1 lane. And even for public transport, if we show the vehicle travel time, and we are speaking about west to west, west to east, for bus, which is a problem there and a good problem there, we see that travel time are very similar. So we may use this. And as we see, even the design 4 has better travel times than design 0, which is current scenario. And if we look to cars, as we see, okay, design 0, design 2, design 4, these kind of indicators, they are good to compare. And we use a lot of Power BI to do this. And this kind of things that we did, we also looked at queues, and let me put here this one, and we make here the comparison. Design 4 has more queue here, but here is on the middle. So, and this was very interesting because we could have that kind of knowledge, and using Vissim, of course. And besides the movements for traffic, we also made an evaluation for pedestrians, and which allow us to see, this is the level of service, the colors. So level of service for pedestrians, what we can relate with the sidewalks width. So if we see the design 0, which is the same as design 2, design 1 improves a little with level D here, okay. Design 2 is the same as current scenario. Design 1, it's improved. The design 3, which is the cycle lane, improved like a level D, it's better. But then design 4, which is the 2 plus 1, improved a lot, level C, and here probably we need to improve something. We have to study that later. And we can also make an evaluation by area. We made simulation of pedestrians by area, and we have this the density of each sidewalk. So this was our analysis for the movements and the simulation. it's a bit complicated to explain this in such a short period, but if you want to discuss later, I'm available. And then I don't know, Francesco, do I have time or not?
We are 5 minutes over your dedicated time slot, so if you can so end in 1 or 2 minutes, so that also Per has time for his presentation.
Okay. Besides current scenario, we also made a forecast for future conditions. And for this, we developed 4 scenarios. One for tourism tendency, okay. We create 4 community visions through the different evolutions for demographic, tourism, social habits, commerce, technological developments, employment, cost of living. We use these 7 key factors to understand. So let's see, demographic, for instance, demographic, we are speaking about if we will keep the tendency that is common nowadays in Lisbon, that the population reducing, or if we are going to have a new inhabitants with immigrants from multi-ethnic, which is there in that zone, is very normal. The most common from people from Bangladesh, Indian are living there. So probably they will be living there in a short period also. So maybe the population will increase. It will have new habits, more people walking or more people using public transport. In the case of generational renewal, which is our scenario 2, probably the local shops are not so important. Maybe they will close, but we'll have new needs for online commerce, online deliveries. So these kind of things that we work when we foreseen the future. I don't have much time, and of course we looked at future land uses in a short period. We will have in a short term, we will have the Hub Creative do Beato, which is a cluster of startups for technology. We'll have in maybe 5, 6, 10, 7 years the new controlled rents nearby. These kind of things will have impacts on the movements and patterns. And of course, new additional transport modes. We are speaking about autonomous vehicles, drones for deliveries. Okay, so according with our model, we related patterns for parking, movements, access streets, crossing movements, public transport use, walking. This was based on the existing current condition. Then we use the annual growth rate for population, for what we forecast as the reduction or increase, the evolution for number of stores. And then we make a relation with transport. And after that, we've foreseen a new model shift, a new model share, how the people will use transport modes, needs for parking, how if we have more people walking or not. And this is the example of 2 scenarios that we made. So the scenario 2, which is generational renewal, we are foreseeing this kind of age structure, which will have impacts on the number of trips and pedestrians. For instance, this is the current situation. For generational renewal, we're forecasting maybe less people walking, because population will be lower also. But for the multi-ethnic neighborhoods, the population is young, more kids probably, and the stores will be more local, more related with community, and the pedestrian movements will be much higher. population will increase also, and number of stores will increase also. So this kind of forecast we saw, and then we use in our model to understand what the impacts in the future may be. And for instance, here the pedestrians scenario 2, the generational renewal, sorry, and we see the needs. So to finish, this was our methodology to develop how we use the simulation to provide indicators to support in the end it will be a political decision if you want to change it or not, if you want to follow one scenario or not. And this is kind of indicators that we used to support that decision, and that's it.
Thanks a lot, Jose.
Thank you.
I think the final part of the presentation on scenarios will help us transition to the presentation of Per Wisenborn from the city of Malmo, a city that within the project has been looking a lot to the future. So please, Per, I will leave the floor to you for your presentation.
Okay, thank you very much, Francesco. I'm not sure if I'm sharing the right thing now. Let's see.
You have using the appraisal tool.
Yeah, is this presentation view or?
It's presentation. We see the back end of the presentation view.
I should switch it?
Yes, try.
Okay. How about now?
Now we see the full presentation.
Okay, great. Thank you. Okay, thank you so much for letting me participate here. I will talk about the appraisal tool, which has not been mentioned very much today. So I think it's going to be very new for you when you see the slides. But I'll make a try here, and hopefully you'll learn something. First of all, Paulo, it's an immense task you have endeavored on, and it's a really good thing that you've done here. And I'm going to give you a very short description of the Malmo part of the MORE project. Really try to be really hasty on this, and then dive straight into the tool itself and just a walkthrough of the parts of it. So in Malmo, our study area is a part of a large redevelopment area where we have a feeder route from the TNT network into the city center, which is our stressed section. This is the future thoughts of layout for the area, and the feeder route crosses right through here. But since this is a redevelopment area, we couldn't do this data collection on the current condition. The current condition is not valid in our work. So we needed to use reference spots, and we chose 6 different places in the city to represent different types of arterial streets in the city to give ourselves different views of how could the new street be designed in our city perspective. This is, of course, current situations also, and we needed to look forward into the future also, which we also did in other types of studies. But one of the really important parts of the project was to also collect data and trying to get a perspective of equality between the different road users and the uses of the street, and the very important aspects of street use and the city as a place and not a transport corridor. Stakeholder engagement was a hugely large part of this work also, where we tried to, at these 6 different reference spots in the city, identify all the necessary needs, the aspects of people using that street, people being there, how they see their street today, and how they would like to see that specific street in the near future or the future. And that input gave us a good baseline to start with the design process of the possible new design of the arterial street in the redevelopment area. So from those dialogues, we suggested that we use these 3 scenarios in our design process, and they were mobility, sustainability, and livability. Mobility would be a representation of big car use, 50s and 60s. And sustainability would be a lot represented by the way we plan today, by focusing on public transport and cycling. And livability would be something that we are trying to achieve more and more now, and see the city as a place to be in, and not necessarily only a place to travel in. So these 3 scenarios created different designs, which we used also in the line map tool. And we came up with a series of different suggestions. And here you can see the 2 suggestions for the livability scenario. And well, the design process, the design workshops needed to be done digitally. So the ones that I showed you before were done in a digital workshop series. And then after that, we also tested the physical elements also in separate workshops. Following that, as Jose was showing you, we also did the simulations and could show the effects of them on a street use level also, and using the new developments on pedestrian simulation and curbside activities. So right into the tool itself that I was supposed to talk about. It has a couple of different parts. It has input data, political and technical assessment part, cost-benefit analysis, and multi-criteria analysis. And I'll just try to walk you through this, and please bear with me. It's technical and nerdy. So it's going to be just slides with lots of Excel-based information, I think, but I'll try to explain it. First of all, we thought that it would be useful to use well-founded assumptions and conditions that would be the basis for how we use this tool. And this is a very important factor for you when you use this tool, because we realized during our use of it that in order to get a good comparison of, for example, different designs, you need to have a common baseline for all the designs, of course. So we inserted these 2 Malmo notes and calculation sheets into the Excel tool itself. And then there's 4 different sheets for input data. And here you input your different design options. Option 0 is doing nothing, and then you have your different options. So we had the mobility, the sustainability, and the livability options. And you insert the design elements here, and you go on in the different sheets to insert different features. Okay, I had too far. So in the end data part of the Excel tool, you it's of course a matter of what you put in that will give you the quality of what you get out of it. The more data you enter in it, I think the better an output you will get. But many of the in-data cells are not completely required, but you have to keep in mind that that will have an effect on the output that you'll get, and you need to take that into account when you do your analysis of the results. So the political and technical assessment part is one of the three ways of doing your appraisal. Here, you put in values like it was showed in the group discussion before, where Paulo was showing the option generation tool. You can choose how to prioritize different modes of transport and different features in your street landscape. So when we did this, we had practically two main basics. Our own SUMP, the Sustainable Urban Mobility Plan, which outlines a lot of how we should work with our traffic environment, and the results from the dialogues and stakeholder engagements. So these two combined will, in our case, constitute the in-data for the political and technical assessment part. And of course, here you can use this tool many times, and you can iterate and test different types of prioritizations. In our case, we wanted to represent more of the civil servant way of seeing it, taking our instructions for how to work and using them here. In another context, you might want to analyze or see what the result would be if you took a certain political view, for example, and then you would have different prioritizations. So the results becomes an overview of how the designs perform depending on different parameters, and on an overall scale, you also get the number of violations of the political priorities, which you have given before, and the number of violations of standards, which are integrated in the tool. And you get, so this is one of the assessment ways. We also tried the cost-benefit analysis, and in this case, we have the national standards for cost-benefit analysis. So we put in the cost for redesigns, and out came a benefit-cost ratio, where unfortunately we didn't have so detailed information on the costs because we're at a very early stage, but just to test the tool, we put in an assumption of this. So you can get a benefit cost ratio here. And in the multi-criteria analysis method, you can enter different stakeholders, for example, or different political views, where you, according to a whole row of different criteria, you get an assessment of which design would be the best of these. And when we tested this, we tested it using, for example, place needs and setting them beside the use for motor vehicle access. And in this case, we do find the livability scenario to be the best. When it comes to the tool itself, as I pointed out before, the quality of your data input will of course greatly affect the quality of your output. So you can choose there, how well you want to work with this. In our view, it's very useful. You can simulate different types of levels of decision making. So you can use it in a working group in a project level, or at a political committee level, for example, to make give you some indications of what would work and what would not work in different constellations. I think one of the big important notes to do is also that it's very instrumental in its use, because you can iterate in this. Do it over and over and try to tweak some different things will give you some maybe different perspectives on how your proposed design will work. And of course, it's really important to keep in mind that you have all your assumptions and your data that you're using into the tool, have them really available, and so that it's easy to do another iteration on this. Francesco, did I catch up?
Yes, that was great. Thanks a lot, Per. Although we had a slight delay, we finished with 5 minutes in advance. I see that there is a question from Meng for you in the chat, so you can read it yourself. I don't know, Meng, if you want to read it yourself out loud and ask the question.
Yeah, Per, I just want to know, you mentioned you have used the CBA, although not fully finished. The discount rate, which discount rate you are using, is based on which regulation or your local decision?
Oh, good question. I'm not completely sure what we used here, because I got figures from our economic colleagues.
Okay.
Sorry.
Well, maybe something to follow up. I see Mario is has activated his video camera. Please ask your question.
Yes, congratulations to the tool who made the tools in the cities. I will speak about something that we talked in Brussels live, and Andor also talked about. It's about how the appraisal tool or the modeling tackle the traffic generation, because we know that when we increase, for example, sidewalks and the level of several sidewalks, there will be increase in demand for pedestrians. And on the other hand, traffic evaporation. So if you reduce capacity on the road, there will be a reduction on demand. I don't know who can talk about this, but it is something that we already talked during the project, so it's more for the other people. And thank you, everybody in the cities. Congratulations for your work.
Thanks a lot, Mario. I don't know. Also, the other speakers are feel free to reactivate your video and camera. So if you want to reply to Mario's question.
I can reply.
Please.
Yeah, that's a very good question. Actually, we didn't consider the full transport and travel demand implications of the road redesign. So I was not involved in the modeling part, but I guess we started with the same demand and we didn't assume that demand will change. So it was a basic traffic reassignment. Either people use those roads or use another roads. But I don't think we consider the long-term impacts on travel demand. And actually that is a limitation, especially for pedestrians. And that is a limitation we encountered in the project. And maybe that can be a base for another project later on in the future. We don't know if when we improve the road quality for pedestrians, what is the impact on the pedestrian flows? How many pedestrians are attracted to the road? People will not walk before. How many people will be motivated to use the road for walking and to spend time in public places? we don't have any estimates of that from any academic study. Is a major gap in this area. So maybe that is something to do in the future. What are the demand impacts of improving our streets? Will pedestrian flows increase? We know probably they will increase, but how much? And responding to each conditions, what improves pedestrian demand more?
Indeed, I don't know if it's also something that, I don't know, Andor, if you would like to add something, or if probably Peter from PTV also has a comment on this. Otherwise, we also have a question from Ivan Sanchez Diaz, who raised his hand. Ivan, if you want, you can also just activate your camera and audio and ask your question out loud. You're very welcome to do so. Or alternatively, you can write your question in the chat.
I can add the question. It's for Per. So, well, very interesting presentations and a very nice tool. And I saw how Per used the option generation and also the multi-criteria analysis, but I didn't see how you used the simulations. Did you estimate the benefits based on travel time savings from this micro simulation in order to get the cost benefit analysis?
Yes, we did. We did, well, at the scenario level, we did what do you call it? Dynamic mesoscopic simulations just to determine the different scenarios and their impact on a higher level, and then down to Vism. Okay. And to test the appraisal tool, we used the same OD matrix for the different designs, just to keep them on the same basis of analysis. So we only let the designs be the thing to what do you say, affect the outputs.
And I don't know if this is too detailed, but so I guess travel time savings are and environmental cost savings are usually done. But do you include some sort of livability benefit, a monetary livability benefit, or that's not included?
We didn't do that in this case. We'd really like to do that. That would be really our next phase, because we see in our city that we really need to work with the pedestrian aspects and the livability aspects and the city as place aspects. So yeah, that would be really our next phase to do.
Thank you, everyone. Very good presentations.
Thanks a lot, Ivan. So we did have like 5 minutes less than expected for questions. So if there are any final questions for, I don't know, Peter, you wanted to react as well?
I have just a short comment on the future demand of pedestrians. That's really not something what Vism could provide the future pedestrian volumes. Like Paolo explained very correctly, because demand is input into Vism, and Vism can tell you what will be the result of the interaction between all the agents in the simulation. So, and assume the correct volume after some design changes, that's really subject for a future research.
This is a very interesting point also from my perspective. So it's something that we are missing, because who uses these tools need to input some data on the demand to see the interaction of different users. I don't know if there are any final comments or questions, because we might take one last question before just thanking all the speakers and participants and close the online session. Otherwise, the presentations would be shared, and inside the presentations you will find the email addresses of Peter, Paulo, Robin, Per, Andor, and Jose, who have presented today. So you are very welcome to contact them via email for any questions you may have. And also the presentations from all the online sessions that we are having will be uploaded to the MORE website. And you will soon also be able to see recordings from last week's final conference and the presentations that were part of the program. So thanks a lot, everyone, to the speakers and participants for today's session. And I wish you a good rest of the day.
Thank you very much. Take care.